Hey, how are we doing, everybody? Let me turn up the volume here a little bit. So we got Dalen in the chat, Cassandra in the chat, Leo in the chat. How is everyone doing? Looks like we're going to start here with some Canvas content and then political party and gender. So we got some great stuff. Mubot is here, a little chill music. Let me write down these questions. We had Canvas content written down last time. We didn't get to it, so we're going to start with that first one right here. Breastfeeding question. Got it. Great job right there. 7 weeks of a long war. Ooh, Canvas content. Chapter 19 or 17/19. Okay. Stat 201. Stat 201. And Leo said gender, political. Wait. Here we go. Chapter 19. Gender and political party. Okay, Stat 201, Chapter 19. Breastfeeding question. When is study day? Wednesday. Oh my gosh, I can't believe it. So quick. And several weeks long war. There's 2 long war ones. Several weeks. We'll say long war question. So there's 2 long war questions. We'll take a look at that. Shira, great to see you here. Dalen and Cassandra, everybody, good to see you here. Let's see, we got the Canvas content ready to go. No, I've been out of it today too, man. Get my last sip of coffee. Got my medical mug today. It's a stats teacher. Taught everything there was in stats. This is what happened to his mind, knowing all the stats. Everyone has the days where you're like, oh my gosh. Here we go. Let's head over to the main screen. Let's do it. Q2 data frame comes from. Oh, good question, my guy, right there. Sorry, everybody. Let's take a look at that. I'm gonna do that one next here. Making the take home. I will do that next, Makai. You got it, because that's a really good getting started question. Makai, you got it. Coming up here next. Okay, you bet. Alyssa, good to see you. There will be a 320 final review. We might do it on Saturday. We should find a good day to do that. Alyssa, thank you so much for being here. Let's make Alyssa a mod. You're now a mod, Alyssa. Thank you for being here. Okay, and we're going to talk about making the take-home here in a second, too. So with this right here, we've got the chi-squared test of independence. So if you're in class this morning, do we use the chi-squared test of independence to test 2 categorical variables? What do people say? You can see all the notes from this morning. Remember, the Canvas content's a great way to think about what's on the test. Do we use the chi-squared test of independence? And I try to highlight things as we talk through this. Sophia, good to see you here. Do we use the chi-squared test of independence, which this is what this chapter covers? Got out. Awesome. Nice. Yeah, definitely let me know. Tell me how those reactive values are going, Dalen. Do we use the chi-squared test of independence for 2 categorical variables? What do people say? I'd write this down on a note. The chi-squared test of independence. Do you use it for 2 categorical variables? What are people's thoughts on this? I need people's help. So if you were wondering about the Canvas content, I need your help to solve this. Do we use the chi-squared test of independence for 2 categorical variables? Do we? Or do we not? What do people think for this one right here? The chi-squared test of independence. The chi-squared test for testing hypothesis of the association between 2 categorical variables. Yes or no? True or false? When we do the chi-squared test of independence, this is what the chi-squared test of independence is. Are we using 2 categorical variables? Notes from this morning. Someone's watching. They're like, Brian, I know it. I know it. True. Priya to the rescue. Priya, you're right. I take a note on that. The expected cell frequency is based on the researcher's opinion. Alpha levels are based on researchers' generally 0.05. But we actually use a what to find the expected cell frequency. What do you think it's not our opinion. There's no opinion on this. We use a what right here. Like the expected cell count is based on a what? It's not your opinion. Your opinion, it doesn't matter. It's based on an equation. So the equation row total times column total over grand total is based on an equation. So row total, so this is very false. That's as false and two. And great job, Priya. Good practice. A contingency table is a key component in understanding the chi-square test of independence. If you take a look at the, literally, I have a contingency table right here. That is a contingency table, which shows us the counts of the observations. These are an expected cell count contingency table. a contingency table is going to show you the counts of the observations right here. And then you could go to the following one, which we're doing the same thing by finding the expected cell counts right here. We did a lot of that today, especially practice at the end during class of finding expected cell counts right here, like an output. Hey, Kaya, great to see you here. We're doing practice, doing the Canvas content. Thank you so much, Kaya, for being here. And we noticed that throughout these slides, a contingency table right here is key with the mosaic plot. So mosaic plot and contingency table are the key components. We do a mosaic plot to visualize it, and we do a contingency table to see the numbers. This is as true can get. We need that. All else being equal, the farther the t statistic falls from 0 in either the positive or the negative direction, the more likely it is that the 2 is statistically significant. So one of the things you could do right here is you could look, Mubot saying hi to everybody. You could go to a t-applet. And p-values are going to be the largest when the t statistic is closest to what? So we're going to a t-applet right here. And if we just do any sort of test, we could do left tail, we could do right tail. P-values are going to be the largest when the t is closest to what? I'm just going to enter in hypothetical values of t. P-values are the largest when the t statistic is closer to what? I'm talking about this value right here if you're watching it. That value right there, so you can watch that. These values are the largest when what? When are these values the largest? These values are the largest when? These values get larger when you're where? Where on the curve are the p-values larger? Where are the p-values larger? So the p-value is the probability of your result given the null is true and the null is at the middle of the curve. So if the null is true, the more probable results would be closer to the center. Does that make sense? The null is at the center of the curve. So when you get a t close to 0, you landed close to the null. If you think about this mathematically speaking, the formula for this when we do the great job, Cassandra right there, 100 points, everybody. So when you do the one sample t test, it's y bar minus mu naught. So what is the least significant t possible? It's when your sample mean is what? So think about the least significant t, which would be 0. How would you get 0 as a t statistic? Because this solves to a t, but we're saying the least significant t is 2 with n minus 1. The least significant t possible is 0. So how would this equation solve out to 0? How would that equation solve out to 0? The bottom, you don't really need to worry about. It standardizes the difference. Think about this. That would solve to 0 when your sample mean is what? The top of the equation, when your sample mean is equal to your hypothesized mean, they have no difference. Like if I hypothesize that the true mean is equal to 8, and then in my sample, I saw that the true mean was, or the sample mean, excuse me, in my sample I saw the mean was 8, and I hypothesized that it's 8, well then I just landed exactly where I expected. And who can tell me the p-value for this test? Now, think about your knowledge. This will hopefully help do it. But who can tell me for 1,000 points the p-value of this test? You just found a t statistic of 0. And you're doing the greater than test. So this is one we could ask on the test. Someone say, wait, we can't do it without the applet. Well, you can, because this one you can get theoretically. If I draw it, you'll see it. Just think about what the t-applet's going to show you. Be like, oh, I landed at 0, and then I'm using the greater than alternative. So for 1,000 points, does anyone know in the chat? We landed at 0, and we're using the greater. So we landed exactly on the null. So does anyone know the p-value? You landed right at the center of the curve, and you're doing the greater than alternative. And that's the answer. So then we asked, well, what is the p-value, which is percent? Priya right there, that's great knowledge. Priya, excellent work. Priya said, well, I landed right here. This is, and we usually do that as a red line. We landed right here, and then we're doing the greater than alternative. So the greater than alternative shades to the right, and Priya found it's 50%. And that's a very, very high p-value. So when you land close to the center, so Priya, you're right, t-stick, there you go. There's the answer. No applet needed. You landed right on the middle of the curve, so your results were very likely, given the null is true. A result higher than your result would occur 50% of the time due to random chance. That's what the p-value means, is at your result or greater than would occur 50% of the time, given the null hypothesis is the true value. And so you would think your result was very likely. And so this question does the unlikely, I believe. Oh, there's Colin. We're talking about Colin today in class. Shout outs to Colin right there. Let me go back over here. And isn't the same for it would be because the less than would be 50% and the does not equals would be 1. So the less than would be 50, the less than would be 50%, the greater than would be 50%, and the does not equals would be 1. Great answers right there, Priya. So the further it is away from 0, the more likely it is that the difference between the two averages is statistically significant. So that statistically significant means low p-value. So when you see statistically significant, that means low p-value, and that is confirmed by going further away, and you can see it's getting smaller. And so the further it is away from the center of the curve, the more likely it is it's statistically significant, i.e. low p-value. You got it, Leo. We're doing that one coming up here in 2 seconds. Thank you so much, Leo. So that is very true. Now, the last one right here I really love because it also deals with p-values. Now, whenever we're dealing with p-values, we need to understand that these p-values have a specific relationship. So the relationship the p-values have is that the less than and the greater than add up to what? So whenever you get p-values here, the less than and the greater than add up to what? Like if you look at a less than and a greater than, the less than and the greater than would add up to what? Great job, Alea, right there. They'd add up to 1. So now that you know this knowledge, we just need to know where is the less than and the greater than. Well, the less than is this one. Notice how it points less than. And the greater than is this one. So can you find me the the greater than p-value? Now, we might not be asked that one for the question, but let's find that. What is the value? So we know that the less than is 0.9934. And so what is the greater than p-value? So remember, these add up to 1. So what would the greater than p-value be? My drawing might be a little bit different in sizes than the actual percentages, but we're just using it as a visual representation that this and this have to add up to 1. So we know that whatever down here is, it's going to add up to 1. So what's the value going to be right here on the next graphic? That's what percent of the curve. It's not visually accurate, but it just needs to add up to 1. You might have found, well, so yeah, don't worry, Kaya. No, don't worry. There we go, Cameron. Cameron swooping in, 100 points. Cameron and Kaya right there. So how would you double check your work right here to make sure you have the right answer for this one? So we found this one. How are you going to double check your work right there? Yep. Priya, that one's coming up. Good question, Priya. That's a tough one. How are you going to check your work right there on that to be like, is that correct? Add them up. And if they add up to 1, you're good. So add those up. Make sure they add up to 1. If these add up to 1, you're good. Now we get to the does not equals alternative. To find the does not equals alternative, so we're going to go right here and draw our curve horribly, might I add. And the does not equals, it's not visually accurate today, but just ignore that. You take this value right here and you what it. You take that value right there and what it for the does not equals. So the does not equals alternative, which is this one up here, is going to be that value whatted, doubled. And you can see it over here. It's this and this right here. It's double the smallest. So can you find that mathematically now to say, okay, the does not equals is double the smaller of the two? Exactly right there, Priya, great work. So the does not equals is double the smallest. So all we do is just take this times by 2 down here. And so we're just going to times by 2. And once we times by 2, people are showing me the answer in the chat, is 0.0132. Do note that the way it describes it here is greater than absolute value, because whether it's positive or negative, it doesn't matter. It doesn't matter because we're just saying it's greater than the absolute value, which could be positive or negative. So that is all them. Ansley, great to see you here. So that is all the p-values. That's the full output we're missing. Once again, know that the difference divided by the standard error is the t ratio. Good stuff right there. And what is the p-value for the does not equals? That's the does not equals alternative right there, i.e. that one. We figured it out. That was the greater than. It didn't ask us that. These other ones, that's usual alpha, and that's the less than p-value. I do want to point out one last thing right here. An easy way to see these p-values is to realize that you're talking p-value is probability. That was on the highlight. So p-values are probabilities. You'll always see p greater than or something. And then you could take these values right here and plug it between these for the alternative USA less than. That's the less than Australia. So that's the alternative USA less than Australia, which we do not have evidence for I think this was differences in heights of individuals or something. But that's got it. That's the Canvas content. We're hopping back over and doing some BAS 320. Then we're doing 201. So stay tuned. Don't leave yet. Okay, we're going to talk about how to make the BAS 320 final. So, we got the 100, right? We got that 100. 10 out of 10 right there. Got to confirm. 10 out of 10. And so let's see. BAS 320. This is how to make the take-home final. This won't take too long. So if you're in 201, don't leave. We'll be doing some 201 in just a second. Okay. Here we go. Let me get the timestamp. We'll be back here to 201. Here we go. How to make take-home final. Let's do this. Okay, so here are the instructions for making your take-home final if you're in BAS 320. Now, this will create an RMD on your computer. Step 1 is to download this file. Step 2 is to load it. We're about to, Jalen. Great question. We get to all that here at KP in just a little bit. Good questions, KP. I'll add that in here. Naive, let me add that over here. And this is how to make, so BAS 320, naive, misclassification. We'll get to that. You bet. I think we have enough time to get to that today. Good questions, KP. So if you notice right here, we're going to load the R environment. We're going to type in the final exam plus your student ID number. That's the only portion of the code you'll change. When you submit your answers, you'll submit them here. Please do not cheat. Please upload your file, but do not send work to people. Do not ask questions of people in the class on how you do this or that, group me or anything. We've had incidents. We don't like it. It's no fun dealing with. I hate dealing with cheating. I say that, and I truly mean it. I hate dealing with cheating. So let's download this file right here. Okay, so then we're going to open up this file. Notice this right here. Now, you might have to open it inside of R. Be careful. Mine knows to open them. You should see this right here. If you've done this right here, you've opened everything correctly. This is what you want to see. If you're on this step, you've done it correctly. If you haven't gotten this right here, or it's opening inside of like R and not R Studio, then you probably need to go to this folder right here, which loads a workspace. So you want to make sure you're where I am right now, where you have that. Now, the most common mistake people do is they click this. You know, no. It's viewing the function. This is the function that creates your thing right here. That's not what you're doing. You're not doing that. It's really just that many lines. Man. It's 160 lines to create your final. So you're not going to click that right there. What you are going to do is you're going to go here to Final Exam, and then you're going to go right here and type your student ID. I got student ID 1, first student ever. When you run this, loading up everything, did I put some packages? Hopefully that doesn't cause issues. I don't think I have those packages. Everyone should have those packages. If it says it doesn't have a package, please let me know. Might find out everything looks all right. Those are just warnings and stuff. Everything's fine. The message you really care about here is at the end. Making final for Final S22 for 1. Placing it in this folder for you right here. This created the data sets. Now, what I would suggest doing is immediately saving this workspace. I'd go here to the save workspace and save this as like final workspace. You could recreate your final to create the same final with your student ID. Make sure you use your student ID. Don't use other people's work. Don't use other people's ID, obviously. But I would save this right here. That's where I would do right now. And you want to open the file. So I'm going to go to my computer. This is in, it tells you where it's at. It's in this folder right here. So I'm going to go right here on my computer. And I'm going to go ahead and open this file. There it is for student 1. And the file is open. There's the file. You do not need to knit this. Do not knit file. Don't worry about knitting this file. Do not knit this file. Awesome, Micaiah. That's great to hear. And thank you for starting early, Micaiah. There's going to be people the night it's due being like, Brian, it won't load. And I'll be like, no. Don't wait till the night it's due. Don't wait till the night it's due. But Micaiah, you should be right here right now. I would save this. I would say save your workspace, save the RMD, save the workspace. The workspace is where all your files are over here. But Micaiah, does that make sense? So at this point, you should have this file right here. Yeah, exactly. Yeah, that's start early, and then you can see everything. If there's issues, we'll alert people. But I've already got some people finishing up on it. It's good stuff. Yeah, so awesome. If you don't get to here, please contact me as soon as possible. If you're like, hey, it won't load, I can't find the right folder, just let me know. Don't wait till it's nice due. Just if it doesn't work, just reach out and we'll get it fixed up. But those are the step-by-steps. Once again, save your RMD, which is this file right here. Save the workspace. That's the button to save it right there. That button right there saves it. This loads workspace. That saves workspace. The workspace is the brain of R. It's where all your stuff is housed. And then, because these are the data sets you'll be using, you could always recreate the file, but I would save it. And then you do not knit this file. You just turn in the RMD as is. It also has your student ID right here. Oh, did it not? Oh, it's the name of the file anyways has it. Okay, good. Should have put where it said the student ID. Yeah. Anyways, that's got it. We're about to do some more 201, so let's head back over to the main screen. This is the back. This is the chill screen. Okay, good work. Oh, it is right below it? Oh, it is! Yep. Helps us confirm that, like, people are entering. Thank you, Makai, right there. Noticing what I don't know. Like, what is student ID entered in? Where is it? Well, this generates your own ID, and it doesn't matter if you put the 0. Rock knows.
It doesn't matter! It matters!
Rock now says it matters every once in a while. Every once in a while, Rock tells us it matters. We gotta load up some Pearson. How are people doing today? It has been a busy day. Finals coming up. What finals do you have? I'm gonna go pick up my marriage license today. Drive down, pick up the marriage license. We're starting off here with gender and political party. This is a My Pearson, or my jump question. It's on My Pearson. But the gender political party, I highly suggest using jump. You could solve some by hand. We'll maybe talk a few solving by hand because that's a little more test relevant. But this question is a lot quicker if you solve it using jump. A lot of these questions will be solved a lot quicker using jump. So I suggest using jump many, many times. Okay, we're going to find that gender political party question. BAS 320, you bet, KP. Okay. Ugh. Gender political party, where are you? Newspaper headlines. Wait, was that it? No. That was the Titanic question. There's the war story. There's one last note in this. Nice little... Oh, found it. Let's put the timestamp. Leo, gender political party coming up right here. And let's do it. Now, what do you think we're going to do here to start? Do you think we're going to do the chi-squared test of independence or the test for homogeneity? What do you think we should do? What do you think we've learned repeatedly? Have we been practicing, if you practice in class, have we been practicing the chi-squared test of independence, or have we talked about the homogeneity test? Just use the, we'll get you. The chi-squared layer right there, great work. We're doing the chi-squared test of independence. We've never even mentioned the homogeneity test, which I think tests to see if things come from one group. Just take that word and throw it out of your head. We're not using it. Won't be on the test ever. So write the appropriate null hypothesis. Now we have a trick. Every time we write the null, what word do we put? Because we're doing the chi-squared test of independence. So what word do we put between them? What is homogeneity? A thing we won't do in our class. So what question, like you put on your note card, what is homogeneity? Something that will not be on the test. We don't use the equal sign this time for the null. Great work right there. So Maria, you'll see this a lot today in class. We'll say the word independent. So we'd want to say here someone's gender is independent of their political party. This is the only one where we don't use the equal sign. I know that breaks the mold. Chi-squared test of independence, we say that X is independent of Y, and just remember, just say it that way. So let's look to see if one of these, oh, well, look. We've now narrowed it down to choices what and what. So now we want to say between choices what and what. Oh, we've only narrowed out one choice? The only choice we know it's not is choice C. Choice C is the only choice because this says not independent. So whenever you think A, B, and D, right, oh, they're Priya. It's not C because that says that's got the null wrong. So now when you look at this, the null hypothesis, and this is the way I like to do it, just think about the complement of it. They're either independent or they're not independent. Like we'll have evidence. And what does not independent mean? That means if somebody is male, they might be more likely to be Republican, which is, I think, what we'll see with this data. If someone is female, they might be more likely to be Democrat. And once again, I'm just going by the data. Males look to be a little more likely independent. Just look, there's more males who are independent. But are these differences here by random chance, or are they big enough differences that we would say there is a difference between someone's gender and their political party? So now we get, are the conditions satisfied? Condition 1, I like to do random. Condition 2, less than 10%. It doesn't mention it. Condition 3 is what? Who knows condition 3 for this? What if I'm doing condition 1 random, condition 2 10%, condition 3 for this is what? I like to do it in this order. Hey, what's up, Kayla? When is the final? I think it's due Wednesday, a week from Wednesday. Core question right here. For 475, do we need to do a stretch table to compare all the models that we made? That would be good. That would be good. That is very good. I don't think it's required. Thank you, Cora, so much. And I saw you answered that question. I was looking at emails and I saw that. And great job, Cora, right there. 100 points. Great practice and great work on that. You said, like, I got this. And I was like, yay! We would have right here the expected cell count, which is cell frequency. That is what I call condition 3 for this. Now, it does it. It is yes, but I want to show you why. The easy condition to check is condition 4, and I do it in this order just because we can do random 10%, and then we pause and we say, okay, what kind of data are we working with? We now have expected cell count because it's chi-squared data. It's the third condition, expected cell count. And then the fourth condition's count data. And for count data, we ask, are both variables categorical? So anytime you're looking at count data, you would say, is somebody's survival a category and is class a category? And that's categorical, bivariate, categorical. So literally the idea of 2 categorical variables. Same day as the take home, I know, right? So busy week. A lot of time, though. A lot of time. Good questions, Kayla. And so we do have 2 categorical variables right there. But here's the issue, and this is what Leo was getting at. We now need to find the chi-squared test statistic. So we're going to use jump to do this. Jump's going to make our life super easy by going copy to clipboard. So with copy to clipboard right here, go ahead and hit Control C or Command C if you're on a Mac. That'll copy it. Then go over to jump, and you need to go to File, New Data Table. I could probably open it early. I think I'm gonna have it open all. No, Kayla, keep asking those questions. I think I'll have it open the whole time or so. I think we said that. Did we say that during class? I feel like we might have. I think we're just gonna have it open the whole time. Why not? You know, do whatever. It's like, more time. This is for 320. If anyone's hearing that, that is for 320. I get to kind of independently decide something 320. Where I'm just like, why not? Because 201 is more of a team thing. It was Cinco de Mayo. Lo siento. Mucho cerveza. This I'm talking about. No. Cinco de Mayo. Okay, now we're gonna go to edit. Paste with column names. Paste with column names. So make sure you get to this spot right here. So I'll repeat the process just in case anyone didn't see. The process is go right here, copy to clipboard. Once you copy to clipboard, hit Control or Command C. So now that you've copied it, go to jump and go to File, New Data Table. This is going to open up a new data table, fresh new sheet for us to work in, and then go to Edit, and then you're going to paste with column names. That is key. No worries. Muchas cervezas. Drink responsibly. Paste with column names. Paste with column names. When you're in your 40, you have to say responsible things. It's a bummer. I miss being in my 30s. So now that you have this data here, you need to do one last step. Go to Tables, go to Stack. Once you do Table Stack, double-click everything blue. So you should be here on the Tables Stack. On table stack, double click everything blue, click OK, and here you are. Now we have two categorical variables, and we have the counts of the observations in each group. A lot of work. You could type it out if you wanted, but this makes sure you don't have to copy paste. So Leo, you should be here on this page right now. And now we can go here to analyze fit y by x. So we're looking at just this. Let me put only this on the screen right here. So we'll zoom in on this so you can see just this. With just this table on the screen, great work right there, Leo. With just this table on the screen right here, you're going to go to analyze fit y by x. And then you're going to put, doesn't matter.
It doesn't matter
which way you put it. You can put someone's there, and somebody's there. Just make sure it's both categorical, and then you need the counts of the observations in the frequencies. This is quantitative, but the questions were, what is your gender? What is your political party? Both questions are categorical, i.e. count data condition right here. And the count is just the observed counts in each group, the frequency of the data. So let's go ahead and click OK right here, and we get our visualization, and we get the answers to the problem. Now, one thing you could actually look at here pretty quickly is you can actually get the expected cell counts for yourself by having it solve them for you in JUMP. Here's all the expected cell counts, and you can see every single expected cell count is greater than 5. This is the expected cell count condition right here, and they're all greater than 5, so we are good on expected cell count, which we kind of just assumed was met. It's important to know what this output is showing you, such as if you have like here the counts, the cell chi-squareds, and we go over this during class, and some other problems today will probably have us find these values. We'll solve them by hand, and we will also solve them in JUMP. Now, here's the thing we should know. What do we do to all the cell chi-squareds? This is definitely on the test. What do we do with all the cell chi-squareds? Like, what do we do with 2, 2, 1, 1, all 1, so 4, 6, 8-ish. What do we do with all the cell chi-squareds to get the chi-squared test statistic? This is your note. To find the chi-squared test statistic, we find the what of all the cell chi-squareds. And the cell chi-squareds are the formula observed minus expected. We sum them up, exactly. And I was doing that in my head right here. And that's the observed minus expected or expected. Great job, Alea, right there. So each one of those is found from the respective observed minus expecteds. These are the observed, and these are the expecteds, and those are the cell chi-squareds. So you would do 32 minus 41.7. You would square that difference and divide by 40. That's about 100 divided by 40, which is closest to that number. So if you sum up all these numbers right there, all those numbers I've highlighted, you will get 8.19. And the reason we find the chi-squared test statistic is to then go to the chi-squared applet, which you will not use on the test, but you do need to know how degrees of freedom are found and such. But you would go to the applet right here, and we need to know the degrees of freedom, 8.19. We'd go over here to the applet. We'd enter in 2 degrees of freedom, 8.19, and there's the same p-value. So take a look at the applet right there, showing the same p-value, a little bit rounded. But does that make sense, Leo, on what you would use this information for right here with the degrees of freedom telling you which curve you're looking at, and then it would plot for you the p-value, which is the probability of your result or result more extreme. Why did you divide? Oh, I was doing it in my head right here, Priya. I was doing a really quick chi-squared in my head of observed minus expected. I was solving the cell in my head. So there's that, square it, and divide by, and then that's what I was saying right here. And that's the value right there. Does that make sense, Priya? So I was just kind of half quick solving it in my head to see like, oh, observed minus expected squared over expected. So I said divide by 40, like 100 divided by 40 is 2.5, but it wasn't quite 100 and it wasn't quite 40. So it turns out to be 2.25. Try solving for these numbers right here. Like notice how I solved that number by doing observe minus expected. There's observed minus expected, square that difference, and then divide by the expected. This is really good practice. If you're watching this right now, there are test questions that literally blank out numbers and ask you to solve them. How would you solve for 32? Let's throw 1,000 points on the board, not 32. How would you solve for 41.7044? What is the mathematics to get? And there's a lot of ways to get that one. If we were to blank out this number right here, how would you solve for 41.7044, which is the expected cell count of males who are Democrat? How would you solve that? Someone in the chat, 1,000 points out there. Really good practice as we solve this problem, get the answers, and then learn how to solve test questions from this. How would you solve that? See if you can do it. Write it down right now. Pretend it's a test question. You're like, oh, I gotta get the mathematics that gets 41.7044, and it's great because we can check our answer. We'll see if anyone gets it right here. We'll give it a second more too, and we'll see who gets it. Remember, this is good test practice. We're just trying to solve for this number right here. That is it right there, Alea. You're right. I'll throw the 1,000 points. So let's do the mathematics. What they're talking about is we need to take, if this number right here was gone, expecteds are row total times column total over grand total. So what's the numbers? Row total, column total. That's how you do it. Make sure to point towards the number. And this is for expected. 83 times 102 divided by 203. Exactly. So try to solve it for yourself. Make sure you get the same numbers. And it's a good check to make sure you know how to solve these. You do get these formulas on the test. And notice how we have just found the same number by doing row total times column total over grand total. Just practice. Be like, oh, it's just row total times column total over grand total. And you do get the formulas on the test. Good solves. Now we're looking for the chi-squared test statistic, 8.19. That's what we wanted for the problem. 8.190. That was the p-value, right? And so now it says use an alpha of 0.05. These are the easy parts where we just make sure we get it. Our p-value is what to alpha right now? Above or below? The p-value is above or below. Is it high or low? What is the p-value here? Is it high or low? The p-value here, is it high or low? Thoughts on the p-value? It's below, it's low. So the p-value is low, reject the null. So we're down to two choices. I reject the null, and there's what? I would say there's not evidence for the alternative, or there is evidence. When you reject the null, what do we say? If you reject the null, what do you say? I reject the null, there's not evidence. I reject the null, there is evidence. So you would reject the null, there is evidence for the alternative. Woo! Great job. We got more questions and really good practice, everyone. I'm trying to make these as test question relevant as possible. So stay tuned. More practice. Here we go. It is time for the breastfeeding question. So just a moment right here as we get this loaded up. Listen to this one. Let me find it. Thank you, everybody. And KP, I think we're going to get to that question. The misclass. You know what's interesting is this stuff could deal with misclassifications because it's matrices. I think is this it? I think this is it right here. Tell me if I got the wrong one because we only got 2 more questions. So drop more questions in the chat because we don't have that many. So KP, we're gonna do it for sure. Let's start with the main screen. Okay, we got some easy stuff right here. Why do I say easy? Because everything we're doing for chapter 19 is the chi-squared what? The war question, you bet. Probably do both versions of it. And then we'll do one version of the war, then we'll come back and we'll do KP's question, then we'll come back to the other version of the war. Don't want to lose people. In chapter 19, we only do the what? In chapter 19, the test we do consistently is known as the what? We have been learning the what? It's everywhere in here. What are we doing? Yeah, manually selecting a REMA, looking at the AC. Yeah, definitely, Cora. Let me put that on here. Chi-squared, so let's talk about some 475. So picking, using ACF and PACF to make decisions. I'm trying to think how much we have on the test on that, but yeah, we should talk over that. We've been doing the chi-squared test of independence. Be like, I am learning the chi-squared test of independence. Oh my gosh, there it is right there. Boom. One question down, chi-squared test of independence. Now, whenever you write out the null alternative, Christian, great to see you here, and Priya and Alea, what is the thing we do when we write out the null hypothesis for the chi-squared test of independence? What do we always do between these two words? We'll find the other one here then, Priya, too. So we'll find the second one. This is, I guess, the easy one, right? We'll do the next one then. What do we always do between these two words right here to write the null hypothesis on this? We just write independent. See right here? So we're trying to figure out, learn how to spell independent. That's what we're trying to figure out. So we want to figure out if a mother getting an epidural is independent of them breastfeeding at 6 months. And so the null hypothesis is that they are independent. The alternative would be that they're not independent. The wording can sometimes change because not independent, we might need to know how to interpret that. The null hypothesis right here, breastfeeding success is independent of having an epidural. It's the only one I see. And then the alternative is going to be that there's an association. There is an association. I would say that they're not independent. Association means that knowing if someone had an epidural would tell you something about their breastfeeding success. I wish they just used the language not independent. You can do that. You can say breastfeeding success at 6 months is independent of having an epidural. Breastfeeding success at 6 months is not independent, which means that there is an association to say like your grade is not independent of studying. That means studying impacts your grade. We're trying to see if there's evidence for the alternative that there is an association that they are not independent. So good question right there on nulls and alternatives. It's important to know a little bit different of wording to know how to interpret it. So good practice on the bottom right there. There's a second one. I think this is it right here, right? So let's do the second problem, version 2. Heading back to the main screen. 1 second. Oh, yeah, KP, you got that. KP, really, really quick on that. This kind of answers your question. We're trying to predict whether or not someone will have breastfeeding success, right? So the naive model, KP, really quickly, because this is literally, like you notice, it's just related to what you're doing, right? And KP, you're right. The model, right here, it's misclass. If we use this as a model, well, see, this is not the predicted. We'd have to have predicted right here. They would have to, if this was predicted success, right? And this is actual. Does that make sense, KP, to what you're asking about? So the naive, that's the naive, right? I've changed this. This is no longer a 201 thing now, because it has to be predicted success with breastfeeding and actual success. The misclassification of your model would be this, and the misclassification of the naive would be how many. Which this is weird because the naive is doing better than the model. If this is the way it was written, because this is a totally different thing now. We're not doing nulls and alternatives on this. And we can do a more in-depth on this. But the naive model would misclassify 480. And so the naive doesn't have this stuff right here. The naive only has the Y values. Yeah, I think we're about to do the other pregnancy one. You bet, Jalen. You got it. That's the naive model right there. It only knows the truth for the Y, and it predicts the majority level, and it gets the minority wrong. So this is the misclassification. Does that make sense right there? Mm-hmm. So the misclassification on the naive would be using only the levels of Y. So you don't look at the predictions of the model. So you wouldn't have this information inside of here, which is the model predictions. You would have just the truth for the Y, like what are the actual values, and the majority level, which is what we predict for everybody, is what we would say everybody will be successful. And then the minority level is the misclassification rate, because we would get wrong the things we misclassify via classification by the majority. Does that make sense, KP? And great questions. Kind of a quick little thing right there. Head back over to the main screen. Good stuff. Yeah, I like KP. Thank you so much for hanging out, practicing along right there. That's why, thank you so much. I always want to big thank you for everyone who joins in, asks questions. Naive classification exactly, or accuracy. Sometimes that's called accuracy. Like how well does the naive model do? Stat to 1, you get to hear all these cool terms right here. We'll say version 1. We're going to do version 2 of the breastfeeding questions. Stay tuned. We got a lot more questions here. Shout outs to everybody who's always here at office hours, whether you're new or you've been here a lot. First time watching, 100th time watching. Time for another Stat to 1 question. Okay, this is the second version of the breastfeeding question. And first thing it asks is degrees of freedom. Now we have a trick for doing the degrees of freedom, and let's practice how to get the degrees of freedom. You say to me, Brian, that's a what by what. Now be careful. A lot of mistakes happen when we see this right here. I mentioned this in class. I want someone to say literally in the chat, Brian, that's a blank by blank. So who's got it? A lot of mistakes happen. We're going to try to find it. Great job right there, Alea. You got it. Brian, that's a 2 by 2. Now someone says, wait a minute. That's a 3 by 3. And we say, no. Because the common error is to count the totals. It's a 2 by 2 because there's 2 levels to each one. So when you get 2 by 2, the formula is to do what? How do you find... Now, how do we get the degrees of freedom from this? We have it's a 2 by 2. There's 2 answers to each question. Don't use the totals. So what's the degrees of freedom now? Is it? What is it? Drop each one by 1. Exactly. So 2 by 2 turns into 1 times 1, and that's the answer. So the mathematics are rows minus 1 times columns minus 1. It's longer to write out. It's better to just realize you're saying it's a 2 by 2, drop each one by 1, and then multiply. So the formula is 1 times 1. You're literally just deleting 1 here, and it's 1. Now, we'll just do one more version right here because we do like to practice and make sure we get it. Brian, that's a what by what. There's how many degrees of freedom. So solve this right here. See if you know the degrees of freedom, which tell us which chi-squared we are using. Degrees of freedom always let us know which distribution we're using, whether it's the t, the chi-squared, or even the f. All have degrees of freedom. So Brian, that's a what by what. And there we go. Priya, great answer right there. It's 2 degrees of freedom. Brian, that's a 2 by 3. Notice how there's 2 levels here. There's 3 levels on the bottom. So the answer is 1 times 2. Great work. And there are 2 degrees of freedom. So degrees of freedom questions are, I think, free questions on the test. If you know how to solve it, especially for the 1 sample t n minus 1, the 2 sample t too complicated, and for this one, it's rows minus 1 times columns minus 1, and you do get the formula on the test. Okay, so we know the degrees of freedom here are 2 by 2, 1 times 1, answer is 1. What is the smallest? And a lot of times people will check the smallest because we want to see if the expected cell counts are what. We want to see if the expected cell counts are what. We'd really like all those expected cell counts to be what? So this is the third condition right here as I go call it by. We'd like for all the expected cell counts to be what? We'd really like for all those expected cell counts to be what? What would we like them to be? Like, at least 5, pretty great work right there. We want them to be at least 5. So think about this. It's like if you go out to the bar and you could tell the bouncer at the door this, you could say, okay, look, we just need you to check our what-is friend. You'd say, like, we're going to tell you the truth right here. We just need you to talk to the what-is friend to see if we can all walk in the door. Because they think if we want all of them to be greater than 5, we could just go to the what-is friend. If we want everyone to be older than 21, we could just talk to the what-is friend. Like, you only need to check one person. We'll just tell you that they're the youngest. So if you card the youngest person and they're over 21, then we're all over 21. So we're doing the same methodology here. We're saying, okay, if the smallest one is greater than 5, then they're all greater than 5. So when you think about the mathematics of this, it's found by row total times column total over grand total. That's how expected cell counts are found. We do a lot of practice of that. So to find the smallest expected, let's go to the smallest column and let's go to the smallest row. Now, this is just coincidence that it is on the 179. That's coincidence. Don't choose 179 because of that. We need to go to the smallest row and the smallest total, the smallest column. Total's always the same. And then we're going to take row total times column total, multiply those together, and divide by grand total. So row total times column total over grand total. RT times column T over GT. There goes expected cell count. And that's the formula right there. Make sure to solve it. And so that's 454 times. There we go. That's the smallest. Is that greater than 5? You bet. So it is this, 2 decimals. There we go. What conditions? They break apart the random and independent. We prefer to talk about it's a randomization assumption. The condition is randomization. So we're good on those. Were they random babies? Sure. Probably. Count data. Count data means both variables are what? It says the data is given in counts, but data will be given in counts when? How do we pass the count data condition? What is the count data condition? How do we pass it? Here's an important slide that tells us about passing the count data condition. Count data simply means what? Which is a lot of times it puts as the first condition, but because you can't do this chapter if you don't have this. So count data is the what condition? 2 categorical variables. So you say, we're asking, Are you breastfeeding at 6 months? That's a yes, no question. We're asking, did you get an epidural? That's 2 categorical questions. So the answer is yes. Bivariate categorical, exactly. So it is certainly count data. Count data gives you counts, hence why it's called count data. Shocker. Oh, exactly. We should look. We'll tell it to start a class. We might have time between sections right here. Good questions. Do you think these 1,167 babies are less than 10% of all babies? I think there's good reason to believe that. That seems reasonable. And then we did see that the smallest expected cell count is greater than 5. So we're good on all those. Does that do it? We got it. Woo! Awesome stuff. Good question. Make sure to memorize your conditions. I go by there being 4 because I wrap these 2 together right here. Good practice on the conditions and decent answers. I wish they just said it's 2 categorical variables because that's what gives you counts. It's like, what group are you in bivariate combination? But this is a good question right here. Time for some more. I think it's time for both versions of the war question we're on right here. So thank you, everybody. Good practice. When do we use drop 1 to test the importance of a variable or to test the importance of a variable with multiple levels? So if you have something like day of the week, it brings in 6 indicators. And with 6 indicators, you can't see the importance of day of the week each day because that is the difference from the reference level. So you would take all 6 levels and remove them, and it drops 1. It does an effects test, which looks at the effect of each variable. So you can find the effect of day of the week by doing drop 1. So drop 1 looks at the effect of each variable as a whole, not just the indicators or different parts of the interaction with indicators. Does that make sense, KP? Good questions. Good 320 stuff. A lot of review. Ask questions anytime. And I'll throw them in here, and I could do some examples with it. We're about to do the long war. There's 2 long war questions. Okay. Let's do both long war questions. Long war version 1 and long war version 2. Let's see. If there was time, can we discuss students in? Yeah. By birth? Yeah. Let me write that down here for you. Stat 201. Chapter 19. Birth and college attended. Yep. Okay, long war time. Here we go. Let's do it. Okay. So this is the long war question. It starts out by asking us the null and the alternative. Now, whenever you do the chi-square test of independence, what is a keyword? We've been practicing this all along. What is a keyword for the chi-squared test of independence? I need someone to say it in the chat. The chi-squared test of independence. What is a keyword right there? The chi-squared test of independence. What is the keyword in the chi-squared test of independence? Independence. So we'd like to say that the site of injury and whether or not it was lethal are independent is the null. And this one does such a good job of listing it out. So the null hypothesis is that the 2 are independent of each other. The alternative we're looking for evidence for is that they are not independent. So null hypothesis independent, alternative not independent. Now it wants us to find all of the expecteds. Now you can do this by hand. You can go inside of here and find each one. Let's find one of them. So what do you want to find? Find one of these for me. You can find, it's not that bad actually if you find all of these. I mean, you'll get a lot of practice if you solve them all by hand, but how would we solve any of these? Take a moment. Remember, you need to do row total times column total over grand total. I'll write the formula here. It's row total times column total divided by grand total. You could actually find 2 of these and find the rest of them. I'll show you that trick. Have you done any of the Canvas content? Yep. Start off. Good question, Zach. We start off, Zachary, excuse me. Start off. Yeah, I think he's pretty right there helping out. Love it. So let's solve this right here. Row total times column total of grand total. Can you help on the difference? Which one are you wondering about, Brent? Let me know. We might have just enough time. Let me know which one. We have a video on all those, I think, though, too. So let me know which one you're wondering about. So find me one of these. Like, find me the expected right here. 51. And which one is, that's the first one right there? Yep, I'll do the jump solve here in a moment. So I think Zachary found the first one. Let's find out. He found this one over here, I think. Okay, let's see. Found the first. Nice job, Zach. So we take row total. Here, I'll draw it on here so you can see it. We take row total times column total over grand total. And it just points in at the cell you're solving for. Like, it literally points in. We give the formula on the test, and it points in on it. Good way to remember it and practice it. 65 times 114 divided by 145. And there it is right there. So what you can do, and you have to be careful, is you can go right here and copy to clipboard. With copying to clipboard, we're going to hit Control-C, and then we're going to go over here to jump, and then we're going to go to File, New, Data Table. I'll pause here for a second. Do you know what video? Calculate the T. I sent an announcement, Brent, with the video where I do a lot of them. I sent an announcement with the video. If you tell me which one specifically, I can probably find it. But I sent the announcement. I said, like, here's video help. I might have it. That one has, like, most of the questions. And then we're going to go to Edit, Paste with column names, because it had a column names. And we're almost, let me think right here. We got to stack this. So we got to go here to Tables, Stack. Table, Stack. On Table Stack, double-click the blue columns. Now that you've double-clicked the blue columns under Table Stack, click OK, and there we go. So now we're going to go right here and go to Analyze. So you should be right here with two categorical variables. Analyze, fit Y by X. We're trying to predict the lethality from the injury site frequency. So make sure it looks like this. Should be categorical. How did you copy the data? There's a button right here. Let me click the button again. The button is right here. And then, hey, Colin, we were talking about you during class. Thank you, Colin, right there. I was giving you shout outs talking about Disney, that you're working at Disney. I showed your LinkedIn. Well, I didn't like, I showed like where it said the financial analyst at Disney, but I was shouting you out because we talked about business analytics. So I was like, Colin, who's a rock star, absolutely awesome, was talking about you. You must have, like, you found it. Nice job for you right there. So good to see you, Colin, right here. Just love hearing that. Colin, I love talking about students who just make me smile. And so I'm really proud of you. When you told me you were working at Disney, that just made me smile so much. Because I know that is your dream come true. And so I'm glad to hear that. And so we go right here. We've got it. We just did everything. And so here is going to be where we can get... Oh, he's so nice to me. I'm clicking the red arrow to remove a bunch of output I don't need. And does this make sense, Leo? You can just put the expecteds right here, and this confirms we got the answer right for the first one. Remember, we went and found that answer by hand right there. The 51.103, we found that by hand, and I'm going to type in all these answers here. Don't make errors. Make sure they're all in the right spot. But does that make sense what we did? I highly suggest finding a few of these by hand because it's just practice. You don't want it to be all magic with entering in numbers into jump and something happens. Oh, yeah, let me show it again real quick. You ready? We'll walk through it step by step. Click right here. Go to the thing right here. Go to copy to clipboard. Now hit Controller Command C. Once you go to Controller Command C, it's saved into your thing. You can close out of this for the moment. Go over here to Jump. Inside of Jump, go to File, New Data Table. I'll pause for about 10 seconds on each thing. Once you go to File, New Data Table, you'll get a blank New Data Table. It's very important when you go to the New Data Table, you go to Edit and then Paste with column names because it has column names. So make sure to paste with those column names you just put in. Edit, Paste with column names up at the top. Now that you've got it pasted, make sure it looks red, blue, blue. You want to go to Tables and then Stack. Once you go to Tables Stack, you're going to stack the blue columns here. So Tables Stack. You're going to double click both blue columns right there. So you've double clicked both blue columns to put them on top of each other, stack them up. So now that you click OK right here, you'll get a new table with the data stacked right here. So now we have the data stacked. You're going to go to Analyze Fit Y by X. Once you go to Analyze Fit Y by X, we're going to put both red variables into, notice how label is the fatality of it. You can change the dip variable names you want, don't have to. So with Analyze Fit Y by X, we're going to put label up here in the Y, and in the column, or in the X, we're going to do the injury site. And then we're going to put this right here. Make sure the data's there. If you forget the data, it'll look the same. You won't get the frequency of observations. So make sure you put the data right there. That's a common error. Common error is to not put the frequency of observations in the data. So you click OK. And once you get it, you go right here. Now this is going to deselect a bunch of the output we have because we just want to look at expecteds. It's giving total percentages for each, like fatal body is 38% of observations. The row percentage right here is of the body, what percent were fatal, of the body injuries, what percent were not fatal. This is the column of fatal injuries, what percent were body, what percent were head, neck, what percent. So if you look, that's the order. We don't want that information right now. It just gives it by default. I'm just deselecting those arrow clicks, deselecting all this. You can actually go down to where the table has nothing in it. And we only want the expecteds, which are right here. So those are the expected values that we have. Do please try this though. Do go back and solve by hand because this is more test relevant to solve by hand. Jump will get you all the right answers. So we have confirmed our answer earlier. Check that earlier part of the video where we solved it by hand. Here, let's solve another one by hand because this is more test relevant than doing everything in Jump. But Jump just gets you right answers. So we love Jump. We go here to row total times column total over grand total right there. And that is going to be the expected cell count for head, neck, fatal injuries. And so 49 times 114. And there it is right there, 38.52. Confirm the answer looking at our Jump output. And there it is right there, 38.52. So try solving those out. Good practice and good work pre right there. So make sure you know how to solve that. Jump's just going to help you get all the right answers. Now here's the thing. 51.51 and 38.52. What you could do is you could actually, well, you don't have the totals. That's a bummer. If you add those up, you will actually get the total down there. So it has to add up to that. We're just going to take the Jump answers and put them in. So one second, I'm going to put this over to the other screen right here. And so, whoops, let me move this a little further over. 24.37, and then the not fatal. 13, that rounds up. And then there we go. Compute the chi-squared test statistic. Now, this is something you might want to do by hand. This one takes a lot more time. You have to find all the cell chi-squareds. But the chi-squared test statistic is this one down here, the 38.358. The Pearson has your p-value. The Pearson chi-squared test statistic is what we use, 38.36. How many degrees of freedom? This is an easy one we should be able to find. Who can get the degrees of freedom? And good practice on this. Love these types of test questions. How many degrees of freedom? Brian, that's a 3/2. So how many degrees of freedom? So how many degrees of freedom on this? Jump also shows the answer, but this one we should know like that. This is a 3/2. So there's the formula. 2 degrees of freedom. 3/2, drop each one by 1, 2 times 1. And so that's 2 degrees of freedom. You could take all this and drop it over to the chi-squared applet. You're going to get a p-value, I think, of 0, basically. The p-value here is it's so ridiculous. If you can't see that, it's so tiny that it basically should just be 0. This is 0 as a p-value. You're off the applet. You're off the screen. Do we have the applet up right now? Your degrees of freedom are 2. Your chi-squared test statistic is 38.36. And think of what you're looking for evidence for. Like, this problem theoretically is asking you, do you think there's an association between where somebody gets injured and the fatality of the injury? Injuries in the limb are way less fatal. Injuries in the head and the neck are way more fatal. This was during a war. So there is a strong association between where you get injured and the fatality of the injury. That's what this question is looking at, and that's what the final statements will be on, is that we have evidence to reject the null hypothesis that these are independent. There is at the we might look at, yeah, we should look at that. We'll probably finish up with that, Brent. Good question. Remember, the T statistic is the difference standardized. And lecture, check out lecture. We talk about how to do it during lecture. We might have done an example during it. So what do we do to the null hypothesis? Check out the start. Check out the start, Shehzad, right there. Check out the very start. We did a canvas content at the start, and wink, wink, wink. I think it'll help you out, Shehzad. So check out that. Check it out at the start. Yeah, big hints. So what should you do right here? The p-value is 0. So what do we do right here? I'm not even going to click the answer, because what do we do if the p-value is this low? The p-value is way below alpha. P-value is super duper 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 low. So the p-value is very low. We reject the null. And there is what? There would be evidence. We reject the null. So we conclude that site injury, whether or not are, so the null hypothesis and conclude that site injury and whether or not it was lethal are not independent. Well, we would see. I don't love their wording. That should be right on there. But we would say there's evidence that the lethality of an injury is associated with where someone gets injured. Like there's evidence that whether or not an injury is lethal is associated with where someone gets injured, which the null hypothesis is it doesn't matter where you get injured. They're independent. You get injured in the head or in the arm, the same lethality. But there's strong evidence to suggest that where you are injured is going to dictate on whether or not it's lethal. Just kind of makes sense. Yeah, it's a tough one. That's one of the toughest ones on here, Leo. That's a tough one. It's got a lot of parts and a lot of tricky parts. We're going to do version 2 of it, and we got time for a little bit more. Let's go do version 2. Good, tricky, tough questions. We're doing some of the hardest ones right here and talking through and practicing solving stuff. So if you're watching along, try solving these with us. And here we go. Let's do it. A certain story, once again, describes the injuries. And so here's the easy parts. Once again, whoops, disappearing. Once again, whenever we talk about the null hypothesis on the chi-squared test of independence, what is the word we should be looking for when we talk about the chi-squared test of independence? And I love it when it does it this way. We should know variations on it and what these words mean. When we talk about the chi-squared test of independence, we want to see that word independent, and that's the null hypothesis. You literally, as we like to say, go between these and put independent. So now we've got the weapon and the injury site. So you go right here and you go independent. You say the weapon is independent of where someone gets injured, or where someone was injured is independent of the weapon. And the way they've described it right here is the site of injury and weapon are independent of each other. I like to put it between to say like site of injury is independent of weapon, and then you do not independent, which is the complement. So they've done it great right there. Now it wants all of those. Maybe double check. So yeah, we've been talking about that a lot today. Good question stays out. I want to confirm, but I want you to double check. Be like, let me look. Let me double check the notes right here and be like, is the sum of the cell chi-squareds? Is that how we find it? Is that during our class we have a lot of teaching to the test moments. So that little symbol is a summation symbol. Maybe. So now this one right here has a lot more values in it than the previous one. Once again, I would suggest just finding one of these values. Someone tell me the value right here. I'm going to disappear, and I'd like for you to find me the value right here. If you really want to get a lot of practice and ace any question on the test like this, we're finding expected cell counts, and I want you to find me just the one that goes right there. Remember, the formula is row total times column total over grand total. If you want a great job pre right there, if you want to get a lot of practice, solve them all. So the formula is row total, column total over grand total, and you multiply, and we're doing it because we're looking for this cell right here. We might have some, there we go. And so great job. Once again, you could find them all by hand, finding it in jump. And I'm going to do this slowly. So there is the answer, 6.07. And you can solve them all, but here's the issue. That takes a while, so I'm going to do this in jump. This solves the answers, and we'll probably get the answers for the rest of it. Remember how to solve that, and solve a few by hand to make sure you're getting it. Here's how to do it in jump. We're going to click the table to get ready to copy it, and then we're going to click right here to copy the table. We get the option copy to clipboard, and once we click copy to clipboard, we hit Control or Command C to make sure it's copied. Now that you have it in your copy, you can close out of these. We're just closing out. Go over to jump. And inside of jump right here, you're going to go to anywhere inside of jump and go to File, New, Data Table. File, New, Data Table. Once you go to File, New, Data Table, you will be in a new data table where you can go, and in the new data table you've opened, click Edit, Paste with Column Names. Now make sure it has column names. This one does, which means it has like headings at the top of it with words. So once we paste with those column names, boop, our data is in here. Now, this data is not formatted correctly for us to do the chi-square test of independence yet. We need to do a step where we stack the blue columns on top of each other. So you're going to go to Tables and then Stack right here. We're going to take only the blue columns. Canvas content. Yeah, we might be able to. Yeah, and remember how we do significance level, because if we do confidence level, So think about here. I think Zach will have enough time. Zachary, excuse me. I have just enough time. What are they're added to the final grade? Good question, Joshua. They're added to the final grade. Get all the points you can from showing up to class and also Discord. So here are the data right there. These are the counts of the observations. Call you Zach? Okay, cool. Whatever you like. Hopefully I'm going to just be like, it's Zach, Brian. And I'll be like, okay. And so right here, we're going to take, okay, we're trying to do, let's go here to analyze fit y by x. Just trying to remember which way it goes. I might have to reverse the table to make it look correct. Analyze fit y by x. We're going to take the categorical variables. I'm just going to throw them in this way, see if it works. I might have to reverse these. And so we have the data, which is the counts of the observations. That's a common error right here to not put the data there. And then we have the two categorical variables, which are red and red. Let's go ahead and click OK. Body, head, neck, limb, we've done it. Because I think that is the way it looked. Nope. It's got to be reverse. Redo, relaunch. Relaunch is going to bring back up the console. That's under the red arrow. You can go back to analyze fit y by x. Or it's not going to do it. Oh. Analyze fit y by x. So you do have to put them in this order. I reversed the order. So it's supposed to be like this when you put them in. Just because I want the table to be the same and make my life easier on entering in those values. So we're going to go to this red arrow. We're going to remove everything. I'm just clicking this red arrow, removing everything. Just removing everything because I don't want to see all of it. It is of no use to us. We only need the expected counts. And look, we get that 6.07 right there. And then I'm going to take this. These are all the values I'm entering in. Just make sure they're in the same spots. Like limb is in limb, head, neck, ground, sword, all that good stuff right there. Let's put this over here. And I'm going to enter in all the values and try to not make a typo. It's very easy to make. Very, very easy to make typos on this. I think hopefully it has a leeway of 100th because it's easy to like round the wrong way. They should put a leeway of 100th because when I 2 decimals. Almost rounded that one wrong. I get spoiled by R where I can just tell it to round for me and be like, rounded 2 decimals. I don't have to think anymore. Oh, we have a failure on one of the conditions. The failure right here is there's not at least 5 expected cell counts on a lot of these. Ooh. Does it mention that? Well, yep, probably does at the end where it says like there's a problem. The chi-squared test statistic is the sum of all the cell chi-squareds. So that's a good thing to memorize for the test, that if you were to find all the cell chi-squareds, which are row total, observed minus expected squared over expected, if you sum up all those values, you will get 7.866. That is the chi-squared test statistic. We use the Pearson chi-squared test statistic, which is the sum of all the cell chi-squareds. So 7.86, and that rounds to 7, so 7.87. Now, Brian, this is a 3x3. Who can help us with the degrees of freedom? This is one of those easy questions I love on the test because, Brian, this is a 3x3, so what are the degrees of freedom? Who knows the degrees of freedom for this? Brian, that's a 3x3. What do I mean 3x3? There's 3 answers to weapon. There's 3 answers to site of injury. So that's a 3x3. Great job. Drop each one by 1, and you get 2 times 2. So there are 4 degrees of freedom. The jump output also shows this, but it's easy enough to say, Brian, that's a 3x3 matrix. So 3x3, boom, boom. Yeah, we could, Sienna, I think we could do another canvas content here. You got it. We'll throw that on here. Find the p-value. Once again, you will not find p-values by hand. You would have to go to the chi-squared applet and enter in your chi-squared value. And this is something we wouldn't do on the test, but you would enter in the chi-squared degrees of freedom of 4, your chi-squared value, and we always plot to the right. And the p-value is 0.098. Now, once again, you should see this in your jump output. Jump's doing a little better estimation of it, probably carrying more decimals, and doing 0.097. So basically the same. There's the p-value there, and there's jump calculating it, the area to the right of the curve, 0.097 rounded right there. 0.097. And we'd ask you to look at jump output or such. So now we are doing this. Does it say an alpha level? Alpha 0.05. Reject or not reject, the easy part that we all like when it gets to the end of the test. Great job right there, Priya right there. Thanks for dropping the applet. Reject or not reject right here. Thank you so much. I'm so glad we have all the commands and stuff. The p-value is 0.097. P-value is high. Just let the null fly. Not reject exactly. When the p-value is low, reject the null. When the p-value is high, just let it fly. just don't reject it. Don't reject. I think we'll do, yeah, we might do that next. More Canvas content. Thank you so much. Due tonight, right? Ooh, it's due tomorrow. The null hypothesis, and do not conclude that they are not independent. This is such a weird phrasing. I'm going to get it wrong because of the phrasing. No, I didn't. We did not have evidence. It should just say we didn't have evidence for the alternative. So we didn't have sufficient evidence. That's weird. We did not conclude the alternative. The alternative is that they're not independent. Sorry for the weird phrasing on that one at the end, but we do not reject the null. I do not have evidence for the alternative. It's the same thing as saying I do not reject the null. I did not conclude there was evidence for the alternative that they are not independent. The alternative was they are not independent. We did not have evidence for that because we did not reject the null. I think we'll do a little Canvas content right here. Might have just enough time. We have birth and colleges. Let's do one more Canvas content, and then we might do 475. More coming up. Okay, we're going to do one more Canvas content. Thank you so much, everybody. We're having a skip in the line because a lot of people want Canvas content. So, Canvas content. Let's do another quick content. We did transformation of the data to make the predictions based on the data. So the great thing is use that in the model specification, Cora. And if you do it in the model specification, it'll untransform it when you make predictions. Great question, Cora. 100 points right there. Doing that with FPP3 in the model specification will untransform for you. Does that make sense? So make sure to use your transformation or differencing in model specification. Also, ARIMA does differencing for you. So good stuff right there. Cora, great questions. Any sort of transformation do in the model specification. Project 2 should be graded no later than Friday. Should watch the end of last class. I was like, they'll be graded no later than Friday. This is my answer to when will they be graded. No later than Friday. I've told my graders that with finals coming up, it's super important that people can see their grades. And I know my graders have a lot... they have a lot themselves. Like, they've got a lot of work. And so I'm like, okay, it's going to be a busy time, but make sure to get these in because it's super important for people to see where they're at. I'll probably be releasing them as they come out, just because why not? And yeah. We got some good stuff right here. We got new stuff we haven't seen yet. So you think ARIMA wouldn't be different in model? Yeah, I wouldn't difference in the ARIMA, Cora, because ARIMA's going to do that for you with the D, with the integrated. ARIMA's going to do that for you. So I wouldn't difference because it'll difference the data. It's going to... Does that make sense? And great questions, Cora. I would not difference the ARIMA. I'd let the ARIMA do the differencing for me because it's going to do the differencing or the seasonal if we do a seasonal differencing. You're welcome, Cora. Great questions. Time for some Canvas content. What are the degrees of freedom for this? Brian, that's a what by what? The degrees of freedom are what? Brian, that's a what by what? We've been practicing degrees of freedom all today, so we should be like this on this. Be careful. You can actually get this one right by doing it wrong. So we're going to make sure we know the degrees of freedom for this. So we can answer. It says the degrees of freedom for this are 5. We should have just said what the degrees of freedom. We should have just said, it is a... Careful. Careful. Priya, and so maybe that's the mistake they want people to make. Let's check it out. This is how we figure it out. Oh, there we go. Correction. Great job, Priya. 100 points right there. So Brian, that is a 5. Whichever way you say it's fine. Rock knows.
It doesn't matter.
2 by 5. So what are the degrees of freedom? Not 6 degrees of freedom. It's a 2 by 5. So how do we do degrees of freedom? We drop each one by 1 and we say 1 times 4. Does that make sense? So, no, that's Zachary. Good practice. 100 points. Mary, we're here to practice. Throw all those answers out there, practice, and then see how to get it. Ask those questions. Solid, great work right there. It's a 2 by 5, so there's 4 degrees of freedom, so the answer here is false. Once again, you could get this right by doing it the wrong way. We don't want to get it right the wrong way. We want to get it right the right way. So it is 4 degrees of freedom. It is false that degrees of freedom are 5. We should have probably just said solve degrees of freedom for this question. Be a better way to test knowledge. I don't know. The chi-square test of independence, cause and effect. Oh, do we like those words in stats? Do we like the whole idea of this causes this proves this? When you see cause and prove, what's the first thing that comes to your mind in this class? I say mo. I said no. Right there, Leia. Good job right there. I don't like those words. We don't talk about cause and effect here. We don't do that here. False. We don't say things cause something. We don't say things prove things. We've been doing the homework and quiz today, Ansley, a lot. So check it out. We got a lot of the questions in this video right now. So Ansley, good question. Probably we've done most of them. We've probably done over 50%. The results of the chi-squared test of independent conclude color choice is dependent on the kindergartner. So what is the null hypothesis? Like if we have dependent on the gender. Okay. So we have right here the two variables, which are both categorical. We have color choice, which is what we want to understand. And then we've got gender, which is the explanatory. So what would be the null hypothesis? The null hypothesis here would be what? The null hypothesis between the color choice and the gender is that the two variables are what? The null hypothesis between the two variables is that they're what? What word do we put in the chi-square test of independence? I would say that these two are what of each other? I'd be like, oh, the color choice is independent. Exactly. So what does it sound like they did to the null? It said they conclude that they are dependent, like they have evidence of dependency. So what does it look like they did to the null, the idea that they're independent? It looks like they did what? It looks like they did what right here? This is a tougher theory question. So they didn't stay with them being independent. They said it looks like there's evidence of dependency. So what did they do to the null, it looks like here? Thoughts on what they did to the null here? Because it said they concluded that there's a dependency. So what do you think they did right here? What did they do? They concluded that they're dependent, not independent. They didn't stay with independent. They rejected the null. So they said, no, we reject the null. We have evidence of dependency here. So let's look at the answers. I think it's pretty obvious which one it is. So which one of these looks to be the right answer? They rejected the null. We just figured out they rejected the null. So if they rejected the null, you instantaneously know this. So if they rejected the null, it'd be because why? Hey, yep, p-value is lower than alpha. Interestingly enough, the chi-squared test statistic was very small. If you get a small chi-squared test statistic, you will actually get a large p-value. Regardless of degrees of freedom, smaller chi-squared test statistics lead to larger p-values. So if you had a chi-squared test statistic that's small, the p-value is going to be very large. And remember, we just said that the p-value was very small. So there could have been a question that said something like a large chi-squared test statistic, but if you had a large chi-squared test statistic, you'd get a small p-value. Small chi-squared test statistics lead to large p-values. So these two are kind of synonymous right here. And then we have the word cause right here. So these are wrong. These are basically the same answer because small chi-squared test statistics lead to large p-values. We can't say the word cause, and we can do a process of elimination just using a little extra bit of theory to help confirm the answer. What is the corresponding level of significance? We're going to do a bonus problem on this one right here because we didn't get an alternate version of it. But it's asking right here, they created a, who creates an 87.1% confidence interval? Now, when you look at this output right here, there's important things to know about this output. We have right here the confidence level, and the confidence level can be used to find out the corresponding test. So if we have a confidence interval of 90%, what is the corresponding alpha level? What is the corresponding alpha level? And alpha is like the percent of the time we would reject the null. So who knows the corresponding alpha level to if we had a chi-square, if we did a test with 90%, a confidence interval at 90%? The corresponding alpha level would be what? What would the corresponding alpha level be? So it says if you make a 9, I've changed the question to if I make a 90%, well, it'd be 10%. Mm-hmm. You're finding the total. We'll unhighlight this for a second. If you have 90% inside, then the question is what percent is outside? Does that make sense? 0.1. So the corresponding alpha level in alpha is usually given as a decimal. We don't usually give it as a percent. Great job there, Brianna and Priya. So it would be 0.1. Alpha is usually given as a decimal. I think if it says on this problem, maybe give it as a decimal. Yeah, it says report as a decimal. We usually say alpha 0.1 or something like that. Now, so what should we do to this value right here to find the corresponding alpha level on the two-tailed test? And so I think the theory behind this problem, which is important, what will you then do to this value if this value right here is your new alpha level? So we'll erase that, or excuse me, confidence level. So that is the new confidence level. So what would you then subtract it exactly right there, Brianna? I think you're figuring it out. Subtract it from 1, which is 0.129, right? Double check my math, 0.129. All we're doing is doing 1 minus. I'll show it. They say show, don't tell. 1 minus. There we go. And just remember, it's the inside outside right there. And there's the answer. Now, the bonus problem I want to do right here, or the alternate version problem, is sometimes this T ratio is not given to you. If the T ratio is not given to you, how do we find the T ratio when we know the T ratio is the following mathematics? The T ratio is the difference between the sample means over the standard error of the differences. Oh my gosh. So does anyone know the mathematics for 1,000 points in the chat? Or the standard error of the differences? That is correct, Priya. So what is that? Writing out all this mathematics. Great job, Zach. Yeah, that's it. Well, there. This is S1 squared over N1 plus S2 squared over N2. And it's just as simple as that because this is the difference. The difference is this value, which is literally the difference. And then we'll do this in blue right here. The standard error, which is mathematically that, is just this value. So it's as simple as taking these two values, and that is equal to the T ratio. T ratio is the T statistic, the T with the degrees of freedom. We don't calculate by hand. It is being calculated correctly. It is being calculated correctly, right? Tell Terry if it's not. Ooh, Terry, what's going on with this? That's an error. I don't know if he put in a random value right there. You know what? That should be generated by the problem. So if this is a problem. The T ratio, don't love that theory. That's wrong. Should tell Terry we need to fix that. Not a requirement, success failure, because that's categorical. That's categorical data. Just to confirm and show you, where's the student data? Okay. Just to confirm for you, the 2 sample T are those values. I promise you. That's because we make up those sorts of questions. Here, watch this. 2 sample T test right here. Just go ahead and take, there is a difference between age and gender. That's interesting. So the T statistic right here. Calculate the T statistic without knowing the T value. Who can do this right here? It's just as simple as this. Calculate the T statistic. This one is made from real output. It's not some sort of test question where you have to put in the numbers and have them change. I think it's just that someone didn't make that number, probably because you're not solving for it, so it might not let it algorithmically change with the problem. Don't worry, because it doesn't ask you to solve for it, so I don't think the problem algorithmically changes it. That I think it is 4.3. Well, we have that, but how are you getting that? How are you getting that? Remember, if you look at this output, it's just that, right? So we go right here. There we go. That's it. There we go. And any decimal differences are just carrying more values further than we can. Where it's like rounded something or something, but it's going to be the same thing. You notice it carries all the way to like the 5th or 6th decimal being exactly the same. There's probably like an extra decimal we don't see at the very end, causing small differences to radiate out. But that's got it right there. Really good Canvas content. Good practice. Yeah, definitely, Alex. Yeah, we'll be doing a review for the final. Maybe we'll do it on study day because a lot of people have different. We might try to do that on, maybe. I don't know. Got a lot of work. Submit the quiz. Watch us get one wrong. No. I saw the 9 and I freaked out. I was like, no way. No way. We'll definitely be doing a review, Alex. Stat 201 on Sunday. We did a Kahoot for 475. Back to the main screen. All right, let's try to do one more question right here. I'm going to send out the announcement to the afternoon class saying it's almost afternoon class time. Hashtag show up. Ooh, we got time for like one more question. One more person has their visualization. Time for one more question. No projects look to have been graded for class 2 yet. Well, maybe there are. There's like 300 left to be graded. A review extravaganzas in their playlist? Why is it in that playlist? Let me fix that. Oh, probably because I created it from their class. Oh, so is that hidden? Is it for everybody? Fixing some stuff. Well, the review extravaganza is unlisted? No, public. And playlists. No playlist. Office hours. Okay, no wonder. Well, there we go. Okay. Review extravaganza. Got it open and ready to go. Had to fix some stuff. Okay, make sure I'm sending this out to the right class. I'm always afraid I'm going to send out like the morning video to the morning class or the evening class, excuse me. And then people in the evening class will be like, wait, when is class starting? And I'll go to class. No one will be there. The playlist is always there, though, if you're wondering. Like you say, wait a minute. Brian, when's class? I say, playlist is always there. Rhea, good to see you in the chat. Okay, here we go. Class in 20 minutes. See you soon. See you soon. Click here. Okay. Good time for one more. Who's been here the whole time? We got time for your question. Hey, Siri, how do I check if I have the max points on Discord? ! Rank. Introductory cost. Yes, Priya. Let me do that one real quick. Do you example of differencing in a model? I have the box cost working, but it won't let me add differencing. I can also... Yeah, message me on Discord and let's try to get some differencing working. You should be able to difference the Y and it should be able to undifference it. Yeah, I think Spanbauer and I were doing some problems with that, like differencing, because we were trying to, because FPP3 is its own sort of like environment, its own ecosystem of way things are done. So message me on that and we'll get that working. Random question, what is the code for running a model with categorical variables? I thought it was, that is categorical Y. That is if you're doing like a logistic model to predict the categorical Y. And then talk. You can get, there's tons of ranks, but the level you have, so just talk, go to the food channel, don't spam things, but talk, interact, meet people, have some fun. Maybe after class you're like, that place is pretty cool. Like we got people there posting their food stuff. I'll tell you, go to the food channel. That's where it's at, in my opinion. Some nights I'll just go look at the food channel and be like, what food are people posting? They've got me addicted to looking at what they make, because there are some people like Alan and Alan. If your name is Alan, apparently you just are amazing at either finding good food or making good food. But shout outs to both of them on the Discord, posting some really awesome stuff. I'm thinking, is it Elle and other people posting just really great food on Discord? We're going to get the introductory student class or something, I think. Priya, thank you for reminding us. Grabbing that question. I'm going to post my food. Oh, that's super. Yeah, post some good food right there. Yeah. And yeah, Discord just, I think once you jump into it, it's like, oh, it's just like channels right here. And I just kind of chat. It's like a chat room. So, yeah. The question is introductory statistics last birth order. Let's go find it. Introductory statistics class, birth order. We did the war question. Okay, let me mark this. We did a little on naive misclassification. Pot F. Thank you, Cora. Cora, I hope I've helped out a lot today. Thank you, Cora, so much. Great questions, Cora. I don't think we're gonna have too many questions on figuring out if the ACF drops off or the PACF drops off. Adam and I were talking over that and we're like, we don't know how beneficial that'll be to students to like go over things that's like, you must know, because a lot of times it's just, let the ARIMA pick it, let it run auto. So don't worry too much about that. And we're making the test as we go. The Kahoot's a great way to know what's on the test. The Kahoot is a great practice. Really gonna focus on the Kahoot. All classes, I like to say the Kahoot's a great way to go. Now, Priya, we've got here a few minutes. Let's solve this question. Here we go. What are we doing? Are we doing the chi-squared goodness of fit test? We talk about goodness of fit early in the semester, not currently. Are we doing the chi-squared test of homogeneity? Are we doing the independence? A, B, or C? Independence, goodness of fit, or homogeneity? We are doing the chi-squared test of independence. That's what we're doing. Next, we have the null and alternative. Now, whenever we do the null hypothesis here, we always say a word between each variable. We have the college and someone's birth order, and we like to say that they are what? Now, don't select answers yet. Try to think of your own answers before clicking theirs to see if you match. If we're talking about someone's college and the birth order, we would say that someone's college is what of their birth order? So somebody's college, the null hypothesis is going to be that someone's college is independent. So the null hypothesis is that they're independent. Let's see if we see that. Ah! College choice is independent of birth order. So independent means that it tells you nothing, where the alternative would be that they are not independent, which means that there's an association. They're choosing to say it that way for the alternative. So the alternative is going to be there is an association. Like they're either independent or not independent. And if they're not independent, they're associated in some way. Associated means like, if I know somebody is the first child in their family, they're more likely to go into this. Like there's an association between this. Knowing one will tell the other. Conditions, we're going to do it a little bit quickly here. Check out earlier video where we went over this more in depth. Randomization means we randomly selected. We also assume independence. 10% means that this is less than 10% of all the statistics students, which I guess it is. Let's assume it. Next, we talk about the expected cell count. Now, I think we might run into some problems right here because we want to check the smallest expected cell count. Now, you might think it's this one, and I hate it. It is. It's not that one because it's 1. It has the smallest row total, well, rather over here, row total and smallest column total. The formula is, it is not at least 5. It might not be. And that's not the expected cell count. That's the count right there. To find the expected cell count, we need to do, I'll show you the formula. Oh, we got it right here. I'm going to rearrange all. We need to do row total times column total over grand total. That is the formula. And thus, 35 times 23 over 240. And it's not. You are correct, Priya. Great work. It's not. And it's not because it's 1. It's because the expected cell count is not at least 5. So it is count data because they're both categorical, but we don't pass that one. Great work, Priya. 100 points. Really good practice right there. And, oh, Alea was saying that. Alea, thank you so much. Alea saying that. How many degrees of freedom? Brian, that's a what by what. It has how many degrees of freedom. Love these test questions. We've been practicing this a lot today that you just like, Brian, that's a what by what. How many degrees of freedom? Brian, that's a what by what. Really good, just quick test question here. So the degrees of freedom are rows minus 1 times columns minus 1. Great, it's a 4 by 4. There's 4 answers to college. And don't use the totals. Remember, we're doing the answers here and the answers here. There's 4 by 4. So that's 9 degrees of freedom. 4 by 4, drop each 1 by 1. Rows minus 1 times columns minus 1. 9 degrees of freedom. Excellent practice. The calculation yields a chi-squared of this with a p-value of this. State your conclusion. The p-value is below alpha, so we are going to reject the null. Reject the null because p-value less than alpha. Reject the null. There is evidence, so we always say reject the null. Love the way this is phrased. I reject the null hypothesis. And look, you've got confirmation. You chose the right alternative because they're talking about I reject the null. There's evidence for the alternative, and the alternative is an association. Confirming an answer back here, we said. So check for those confirmations on the answers. So this is a weird, I don't love question F. It just goes into the problem with failing the condition. It's a little more statistical theory than we really need. This is not a good candidate for test question. Like, not a good test candidate question right here. I need an alarm. So I wouldn't do this as a test question. Since some cells with expected cell counts less than 5 have large residuals, any conclusion may be suspect. Yeah. So it's talking about we failed a condition right here. Yeah. Just if you fail conditions, then you might be problems. So don't worry about that. Not really good for the test. It just kind of says maybe your results are suspect right here because you failed a condition. That'd be a better way. Like, do you have any concerns? Yes, I failed a condition, so maybe I shouldn't be doing this. Maybe my results are not accurate. Well, that's got it. Check out today's video. We did a lot today. There's the morning class right here, but check out today's video. There's the list of timestamps, which will be added to it. You know what? A lot of people are probably using this as we speak. So let's head back over to here. I think this is the current office hours video. And if you reload this video now, I need to do this at the end of office hours. I need to just go in and put them in. And that way people don't have to wait till later in the evening. If I just do it as we speak, and then I can take some time off of my, maybe I should do it at the end of class, just put them in. And what am I waiting for? You got the time, so just put them on that at the video. Anyways, talking to myself. You're welcome, Priya. We got class here in 11 minutes, so I'll see you soon. Swing on by. Remember, we're just going to practice. We're going to do more work. Ask those questions. We got this, everyone. I'll see you later. Bye for now. See you in 10 minutes.